This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 10 problems from the March 2025 Digital SAT Math section. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through these 10 problems from the March 2025 Digital SAT Math section, this is basically video or worksheet number 1. Please keep the following things in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, these are all self-reported questions from students that took the March 2025 Saturday exam, and there's also a couple school day ones as well. So please keep in mind that most of these questions are going to be done as free response. However, on a official test, they may have been given as multiple choice questions. So if they were multiple choice questions, there might be other methods you can use to solve the problem as compared to, the free response examples that I'm looking at. So that's the first thing to keep in mind. And then related to that, these are just what students had self-reported or remembered. So there could be some details or some specifics or different numbers or other things that are missing from these problems. I've tried best to, gather the information and work them out and make them make sense, make the numbers make sense. But these questions might be, slightly different than the actual one that you had on your test. Okay, just because again, I'm going from what people have remembered from the test. I do not have a copy of these tests in front of me. Let's see, what else? With that being said, some of these questions are going to be repeats from previous videos. I've tried to typically put those towards the end, usually in questions 7 through 10. So, they have been reusing questions on exams. And last thing, of course, I'm going to be working these out using multiple methods. So showing you how to do them in Desmos whenever possible, and of course showing maybe the traditional way to do it by hand. And if you're interested in learning more how to use Desmos, please do check out my Ultimate Desmos Guide to Digital SAT Math. It's over 3.5 hours of tips, tricks, instruction, 45 practice problems, to help you master Desmos for the test. All right. And sorry, last thing, there's a PDF file which has these questions in it. Link to that will be in the description of the video and also pinned comment of the video as well. All right, so with all that being said, let's go ahead and get started on question number 1. Again, this is from the March 2025 test. This is worksheet or problem set number 1. Okay, so here you have a quadratic equation, and it has r in it, and r is your variable, okay, but q, it also has a q here, which is basically just a constant. And you are told that this equation has no solution. What's the largest possible value of q? All right, so the way you would do this by hand is you would get everything over on one side equal to 0. So we're going to go ahead and we're going to subtract over the 8r and also add the 69 to move that over from the right to the left. Okay, now everything's equal to 0. And then we can go ahead and set up the discriminant. B squared minus 4ac. With it having no solution, we want it to be less than or equal to 0. So here's the thing. The b term here, technically, these two things together make up the middle term, or the quote-unquote the b term. So really the way you do it is you factor out an r, your common factor, and then you're left with q minus 8. So b is really equal to q minus 8. A here is just the 1, and c, of course, is the positive 69. So if we go ahead and plug that in, you have q minus 8 squared minus 4 times 1 times 69. Again, we need that all less than or equal to 0. If you multiply 4 times 69, you should get 276. And then you have still q minus 8 squared. And then you get q minus 8 squared is less than 276. Now, this is a quadratic inequality, so technically, really what we do is we square root both sides, okay, and you get q minus 8 to less than. You can leave it as root 276, or you could just technically approximate it to whatever, 16.6 for now. And really what's going to happen, if you think about this on a number line, is you need these values, like the q minus 8, when you square it, it's obviously going to be positive, and that means it's going to, you need to be less than 276. So really, you want the values to end up being between negative root 276, or 16.6, and positive root 276, or 16.6. So in other words, if you think about it on a number line, like here's the root 276, here is the negative root 276. Basically, the q minus 8 values are going to be like everything in between here. Okay? Everything that is essentially in between here. Now, to get the actual value of q, you still have to add 8, and you have to do it to both sides. So you end up with something like it's negative 8.6132 less than q less than, just slide over here, 24.6132. So since they tell you q is an integer, the largest possible value for q is going to be 24. So 24 is going to be the answer to this problem, what you would select. Now, just to confirm a couple things, and then I'll show you also how you could do it in Desmos using the slider. So first of all, so there's the square root of 276, that's the 16.61. And then, of course, if you add the 8 to it, there's the 24.61 for the upper boundary. I mean, the lower boundary we're not really concerned about, but just to confirm, there's the negative 8.6132. You should be able to as well. Let's see if it'll graph this out. Now, I have to use x instead of q. Yeah, so see here, if you just take the, like, after you move the negative 276 over to the right, and you have q minus 8 squared less than 276. So you can go to Desmos here, and you could just type this whole thing in, solving this quadratic inequality, and you can see right here, basically all the solutions are between the negative 8.61 and the 24.61. So if you don't fully understand how to solve a quadratic inequality, that's fine. You just go to Desmos, type it in Desmos, and you can see right here, these are all the solutions. So what's the largest possible integer value? Well, it's going to be positive 24, and there's your answer. Now, if you want to do the entire thing in Desmos, then what I would do is I would just graph this out. Okay, so I'm going to graph actually y equals left side. I'm going to replace r with q. Excuse me. I'm going to replace r with x. Then I'm going to graph y equals right side. Okay, now I'm going to add the slider for q. Basically, I want there to be no solution, meaning no intersection points on my graph, which, as you can see right now, I zoom out, there's no intersection points. They get further apart here, you know, as the x increases. So really, this is the area I'm concerned with. And then you can just slide this. Notice, zoom out, there's still no intersection points. So let's just bump it up to 50. I'll also set the step to 1 because I only want integers. All right, and now, notice, still no intersection points, but they're getting much closer. 23, do they intersect? No. 24, do they intersect? Still no. You can see there's white space between them, but notice when I click to 25, now there are intersection points. There's one here and there's one here. At 25, there are solutions. At 24, there are no solutions. Therefore, this confirms correct answer is 24. All right, let's look at the next one, number 2. So here you have a basic ratio with a and b, and then you have another ratio or equation with a, b, and n, and wants to know what's the value of 1 over n. So the way you do this by hand, kind of theoretical way, is first divide both sides here by 4, and you get a over b equals 3.5 over 4. Now, go to this other equation and replace the a over b part with 3.5 over 4. And then on the top, it's just 3.5. On the bottom, okay, notice you also have an n, and then you have 14. So now to get 1 over n, basically all we're going to do is, I mean, you could cross multiply, but really I'm just going to multiply by 4 on both sides and divide by 3.5. Cancel, 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 cancel. On the left side, you get 1 on top and on bottom. And on the right side, this you can just do in Desmos. I mean, it's 56 divided by 3.5, but it turns out to be 16. So the value of n is 1 over n, is equal to 16. Now, here's how you could do this entire problem in Desmos. What you have to do, at least this is based on what I found, the first equation, you need to solve it for a or b. So I'm going to technically take the first equation, I'm going to solve it for a. So you do have to do a little work in that it's like 4a equals 3.5b and then just divide by 4. And if you can do that in your head, that's fine. So I'm going to do a equals 3.5b over 4. Then I'm going to add a value for b. Just pick 1. It doesn't really matter. I'll show that to you in a second. Now you can type in the second equation, but using regression. So a over bn tilde equal 14. Notice here, as I slide the b value, n is not changing. A is changing, but n doesn't change. Notice in the regression, it stays constant at 0.0625, okay? And now, we just want to know what's 1 over n. Well, it's 16, okay? And again, notice as I do this, I have to scroll up here. As I move this b value, the 1 over n doesn't change. It stays fixed at 16. So, correct answer to this one is just 16. All right, next up, question number 3, bottom of the page. This problem involves the triangle inequality theorem, and the basic idea is that any two sides of a triangle added together have to be greater than the third side. So ignore this diagram, which is obviously not to scale, but basically what's going on here is you have a side that's 113, you have a side that is 111. So let's call this x. Basically, if you add up any two sides, it has to be greater than the third side, the remaining side. So like x plus 113 has to be greater than 111. Well, that doesn't really matter because if you solve this, you get x is greater than -2. Okay, obviously, has to be greater than -2. That you can just ignore. And then if you pick the others, for example here, 113 plus 111 is greater than x. Well, x just has to be less than 224. Like, okay, that doesn't really help us. But now, if you pick the third pairing, which is right here, x plus 111 has to be greater than 113. Therefore, x must be greater than 2. So which of the following cannot be the length of PR? The correct answer is A. It cannot be 2 inches because then 113 is not greater than 113. It can't be equal to it. It has to be strictly greater than it. So correct answer for this is 2. Also, just if the problem was slightly different and it asked for like the range of the third side, again, it would be like it has to be between 2 and 224. It cannot equal those. It has to be strictly be between those two values. All right, next up, question number 4 at the top of the page. We have another quadratic which has some, excuse me, which has a constant in it. So for this problem, they give you, this is actually an expression. I'll fix this in the PDF file to make it an actual function. But they tell you that -88 is a solution to this, and they want to know what the value of r is. So all that means is when you plug in -88 plus 8, 8 plus 8, okay, you are going to get 0 as your output. So you just go ahead and you can make this -80 and you can make this -80. And then, let's see here, we're going to multiply this to make it positive 6,400. And then 6,400 minus 775 should be 5625. Let's just go to Desmos to confirm that. And you can type the whole thing in just to be safe. So we have, right, this part and then minus 775. Yep, 5625. And then I'm going to move this term over to the right by adding it. So it's equal to 25r squared. Divide by 25. R squared should equal 225. Again, we can just confirm this in Desmos. Yep. And then the square root of that is just 15. So what is the value of r? Well, the correct answer is 15. And this is what you would put in as your answer. Now, of course, you could do all of this work in Desmos. Basically, all you have to do is just replace the z's with the negative 88. Put in an r, and then do regression and set this equal to 0 because it tells you that that number is a solution. And then right here you can see you just get r equals 15, and that's your correct answer. So again, all the work for this, well, you can just do in Desmos as regression. All right, for the next problem, here you have a right triangle, and we're told that C is the right angle, so I'm just going to put A at the top and B at the bottom. We know BC is 174. We also know point E is somewhere here on side AC, so here's point E, and we know point D is on AB right here, and they're connected. We draw a line segment between them, and that line segment is parallel to BC. Okay? We also know AC equals 2EA. So what that means is, if this is x, then this whole thing here is double that, or 2x. So what that also means is that EC is technically equal to EA. In other words, these are both the same. So what you end up here is a situation with similar triangles. The reason these triangles are similar is because if you look at the one on the top, ADE, and you look at the large one overall, ABC, you end up with at least two pairs of congruent angles. You have angle A, which is the same, which is shared, and then you have a right angle here. This will also be a right angle because corresponding angles formed by two parallel lines are congruent. Therefore, AED is congruent to ACB, so they're both right angles and so on. So these two triangles are similar. So what that means is, so we have this x and 2x, we have this 174. We can match up the corresponding sides of these triangles. So in other words, DE corresponds to BC, which is 174. And then we can say that AE, we don't know its value, but we could just use a generic x and match that up with AC. Again, we don't know its value, but we can use a generic, 2x. Because basically all we're concerned about is the ratio is, 1 to 2 from small to large, or 2 to 1 if you're looking large to small. So the point is, like, these x's cancel out, and really, on the right side, this just becomes, 1 over 2. So 2DE equals 174, or in other words, DE is just half of 174, which is just 87. All right, so the correct answer to this problem just ends up being 87, and that's what you would fill in. Next up, let's look at question number 6 at the bottom of the page. So here you have an equation of a circle, and they tell you it's got a couple constants in it. They tell you that it intersects both the x-axis and y-axis once each, meaning that it's tangent to both the x-axis and the y-axis. So they want to know what is the value of q and w. So, all right, here's the thing. First of all, notice here k is equal to 34, meaning the y coordinate of the center is going to be up here at like positive 34. That means that like if you have a circle up here, regardless of where the center is, wherever you move it, for it to just touch the x-axis, the radius will equal exactly 34. Okay? So in order for it to, again, touch, because if it's more than 34, it would go through twice. If it's less than 34, it wouldn't touch at all. But to touch it, just be tangent to it, the distance here, which is 34 units because the k value is 34, has to be equal to the radius. So that tells us the radius is 34, which also means that w, which is r squared, is just equal to 34 squared. 34 squared is 1156. Now you can apply the same basic property, or same basic idea, to find q, which is that for it to be tangent, in this case to the y-axis, the q value has to be equal to 34. Because, again, for it to touch, basically the radius has to be equal to the horizontal distance that the center is away from the axis. Otherwise, if it's too far, it would intersect it twice. If it's too short, it wouldn't intersect it at all. It has to be exactly 34 to just be tangent to it and touch it one time. So therefore, right here, Q is technically positive 34, which means really the center of this is at negative 34, positive 34. Yeah, it's right over here as I've drawn. But we don't necessarily care about that so much. But now we have Q and W, and we can add them together, 34 plus 1156, and we can get the correct answer, which is just 1190. Now, you could technically, I guess, go into Desmos and try to do this with a slider, but I don't think it's going to save you that much time because you still need to know that the radius is 34. So you're already going to have to have figured that out, to get it to intersect the x-axis once. And then when you do that, you would see that it would be the same for the y-axis. So meaning I don't think there's a short, quick, easy way to find this in Desmos. Next up, question 7. Now this is a repeat. This is one that first appeared, I think it was on June. It was either May or June of 2024. It's the predator and the prey question. The method that I recommend solving this, is picking numbers. And so what I'm going to do is I'm going to start for both groups, predator and prey, with 100. Okay? The predators increased by 240%. So that means we're adding 2.4 times the initial amount of 100. The prey increased by 1900%. So that means we're adding 19 times 100. So our new values after the end of the first week are 340 predators and 2,000 prey. Okay, the number of predators is p% less than number of prey. So the way we can find that is basically just finding the percentage difference between them. So we're going to take the 2,000 for prey, which is the larger one, subtract the 340. The difference between them is 1660. Now, we have to divide that by the 2,000, the number of prey. The reason we do that is because of the way the wording is here. It says the number of predators is p% less than prey. So since we're doing less than prey, i.e. we're comparing, basically we're using prey as the comparison or as the value that we're finding the percentage less than. We're saying 340 is what percent less than 2,000. So because we're comparing it to 2,000, that's why that goes in the denominator. So then you just divide these. It comes out to 0.83. And then you could go ahead and, of course, just multiply this by 100 because it says p%. That means for the p-value, they want the actual percentage, which is 83. They do not want the decimal equivalent of it. And again, I'll just go to Desmos to confirm all these calculations are correct. So let's see here. What should I'm going to call predators D, 100 plus 240% of 100. I'm going to call prey, just whatever, I'll use Y. That is 100 plus 1900% of 100. Okay. And then I'm just going to do Y minus D divided by Y and times 100 for the percentage. Yep, we get 83%. Okay. Next up, let's look at question number 8. So here, this is a repeat question as well. This one was featured in 2024. You have this map, and you're told it's 55 inches long on each side. Okay, And you also know that basically 1 inch is equivalent to 19 miles on the map. So that means basically this entire side length, 55 inches, corresponds to 1,045 miles. Okay, again, just multiplying 55 by 19. All right, now the map sides are decreased by 65%. So you can either do 55 minus 0.65 times 55, or the shortcut way is just 55 times 0.35. But either way, if you do that in Desmos or on your handheld calculator, you should get 19.25. Okay, so let's just so far take a second, confirm both these calculations are correct. So again, the 55 times 19 is 1045. And now, 55 minus 0.65 times 55, okay, 19.25. So basically, now they want to know what's the distance that 1 inch represents on the small map. Essentially, like, what's the scale factor? So the thing is, you still have the same 1,045 miles being represented now by only 19.25 inches. So you put the 1045 miles on top, you put the 19.25 inches on the bottom, then when you divide these, you're just going to get a number of miles, and then it's going to be over just 1 inch, which is what they're looking for. So just go back to Desmos. Now you can just take this 1045, divide it by 19.25, and there is our answer. So notice it comes out to 54.28 or 54.29. Basically, if you round it, you get 0.28. Or sorry, you get 0.29. You round because the 5 rounds the 8 up. If you truncate it, you get 54.28. Let's see if there's a decimal. 1, 2, 3, 4. Yes, you could also technically put in 380 over 7 if you wanted to. Okay? So any of these would be acceptable as correct answers. Again, 380 over 7, 54.28, 54.29. But this is how you do, this problem. All right, so let's look at this next one, number 9. This is also a repeat question that has appeared on multiple exams in 2024. Basically, what you have is a rectangular region here, and there's a bunch of small individual squares. Each of these small squares has an area of R, okay, and there's a total of 40 of them. So the area of this entire rectangular region is just going to be 40 times R, because there's 40 of these little individual R's. Now, we also know that the length is 1.6 times the width. So this is W, this is 1.6 W. And we know the width is x root r. So let me just now replace this. So the width is x times the square root of capital R, and that means the length is 1.6 times x square root capital R. So now what you can do is you can set the 40r equal to the length multiplied by the width. And so you notice what happens here. Root r times root r is r. X times x is x squared, and we still have a 1.6 in front. The r's will just cancel out or drop out. So it doesn't matter what r stands for. It's just, it's going to cancel out of the equation. Then you can solve this by just dividing by 1.6. This turns out to be 25. Again, all this solving, you could do this in Desmos. You could just do a regression statement, get it in one thing. And therefore, x is going to equal 5. We can square root both sides. We can ignore the negative 5 because we're only dealing with positive values because we're talking about distances, side lengths. So the correct answer to this, what you would fill in, what you type in, is just 5 for x. All right, the last question here, number 10. Here we have an equilateral triangle. Okay, again, ignore the very poor drawing. We know its area. We know its height is k minus 7 times root 3. k minus 7 parentheses, okay, root 3. Notice since it's equilateral, this is 60, this is 60, and also up here it's split, this 60 split into 30 and 30, because when you have an equilateral triangle and you draw its height down the middle, it splits it into two congruent 30, 60, 90 triangles. All right, so the way that I would do this is I would note that this height is across from the 60-degree angle side. Therefore, to get the side right here, which is across from the 30-degree angle, i.e. the short leg, you take the side across from the 60 and you divide it by root 3. In other words, k minus 7 root 3, you divide it by root 3, so this becomes k minus 7. And that's going to be true for this, basically for the other, congruent triangle as well. Now you can make an expression for the area of a triangle, which is just 1/2 base times height, and you can plug in the base and the height in terms of k, and you can solve for k. Because the base is going to be these two things added together. So it's 2k minus 14, but I'm going to write it as 2 times k minus 7, and I'll explain why in a second. So again, this is the base, these two added together, and the height is k minus 7 root 3. Okay, so this is the equation we're working with. So notice a couple things. 2 and 1/2 cancel out. The root 3's will also cancel because you can just divide both sides by root 3. So they cancel. Okay, and then so far on the left you have 25. Over on the right, notice you have k minus 7 quantity squared. You do not need to multiply it out. You don't need to FOIL it out and then whatever. It's so much simpler to just keep it like this and now just do the square root property on both sides and get k minus 7 equals 5. Technically, you put a plus or minus, but again, we're dealing with side lengths, distances here. We're not concerned about negative values. And then you can go ahead and add 7. So we get k equals 12. Now, technically, yes, you do have negative 5 here, and if you add 7, you do get a positive value for k of 2, but that's not going to be an acceptable answer because when you try to plug that back in to the problem, the values you get for the height and for the base or for the side lengths are not going to be positive. Okay? In other words, 2 is going to be negative 5 root 3, and that doesn't make sense. Here, it's going to be negative 5 and negative 5. The whole thing would be negative 10. Again, that doesn't make sense. So that's why we can ignore, cross out, eliminate this thing. And the correct answer for this that you would type in would just be positive 12. All right, so I hope you enjoyed this video, which went through 10 self-reported problems from the March 2025 Digital SAT Math section. Of course, if you have questions or comments or alternate solution methods, please do feel free to leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, be on the lookout for the other March 2025 videos. I plan on making 4 of them in total. And lastly, again, if you're looking to improve your knowledge of Desmos, please do check out my Ultimate Desmos Guide to Digital SAT Math. Over 3.5 hours of tips, tricks, instruction, and 45 practice problems to help you master the Digital SAT Math section.